Hello, in this video we are going to see how I select the steel to use for the top plate of the anvil. Here you can see in my previous trial when I tried to weld the mild steel to the leaf spring, there were many cracks and air get in, there is corrosion everywhere. I split the plate, the top plate from the main body by hammering, and you can see here details. So I decided to make some experiments of steel, and I took mild steel, steel from a plow, the plow and the leaf spring steel that I used before. I put them inside the freezer on purpose to 20 degrees minus negative centigrade, and I welded with 7018. I took some slices, you can see here mild plow steel, polished the slices to 600 grit and etched. You can see here the mild steel at the bottom and the weld at the top. Here the plow steel at the bottom and the weld, the 7018 weld at the top. And in the next slide here you can see the leaf spring steel and the 718 at the top. Now I took a stereoscopic microscope like this one and made some pictures, not so good because I do not have equipment to make good pictures, but this is more or less about 10 times amplification, and this is the mild steel at the bottom and the weld at the top. This is the plow steel at the bottom, no cracks as you can see, and the weld at the top. And now we are going to the spring steel, and you see there are cracks in the interface between the weld at the top and the spring steel at the bottom. To make some experiments to check how the steel, the top plate steel that is welded to the main body of the anvil is going to react, I decided here I have a little bit of the same steel that I made the top plate. I forged it to these dimensions, and now I'm going to use these two bits of one of them or two of them. These are mild steel, and I want to make a simulation and make some different heat treatments, and I'm going to weld it over here, okay, with the 7018. So this round stock is going to be a simulation of the main body of mild steel of the main body of the anvil, and this is of course the top plate. Okay, I have these two bits. I'm going to clean them, cut them to size. One is going to come over here, and another one is going to go over there, and we will see what are the heat treatments that I want to make. Okay, after welding here this round stock to this is the steel, the same steel as the top plate of the anvil. I'm going to simply discard these two bits, okay, and I'm going to make the heat treatment of these three bits over here. This one I'm just going to warm up to non-magnetic and normalize it. I suppose one of these I will dip it in water, quench it in water, and one of these I'll quench I suppose with a mist or with a spray from water to simulate the way that I can quench, the anvil with buckets of water and spray. So let's check if this is non-magnetic. This is the first test sample. It is air cooling. Okay, non-magnetic, as you see. Air cooling goes over there. Sorry. Okay, so let's go ahead and now in this sample I'm going to quench in water. Let's see if it is non-magnetic. Non-magnetic, here we go. That's it. Now let's see if this is non-magnetic. I'm going to cool this in a shower over there to see if this is non-magnetic. Okay, non-magnetic. Now this is a simulation of the way that the anvil is going to be quenched, because I don't have a big enough water flow to quench it, so I'm going to use this shower together with buckets of water that I'll be dumping on top of the anvil. Now to test further the steel, how the steel reacts to heat treatment, I cut these 3 small samples from these test bits of stock that I prepared, that you saw me quenching. Here this is showered quenching, this is ordinary quenching, and this is normalizing. So I'm going to polish both sides here with, this is 40 grit flap disc. Now I have here this pad, okay, for the angle grinder as well, and I'm going to polish each one of the faces with the 120 grit. This is 180, 360, and finally 600. This is what I have, and finally it goes over there inside the muriatic acid. And I'll show you the results then from the microscopic observations. Well, the reaction is a bit stronger than I thought. I think that I'm going to leave this here 20 minutes, half an hour, remove it, and look under the microscope. In these images you can see that even in the normalized steel there are some cracks over there, more or less by the center of the image. And of course, as it is expected, in the ordinary quench in water steel you can see more cracks in the interface between the weld at the top and the steel at the bottom. Now here there is another image. You can see more the plow steel at the bottom and the weld at the top. And in the shower type of quench you can see as well some cracks. This is crack in the plow steel itself. I use here several amplification. I'm not so sure this is the least, it is like 6 times. And here it is the single crack that I saw between in the interface between the weld at the top and the plow steel at the bottom. So I decided that I'm going just to use the shower to quench the top plate steel, and that's what you are going to see in the next video.